Machine learning and artificial intelligence. So far on this podcast, we have discussed the benefits and drawbacks of complex machine learning algorithms. But how do they actually work? Today, Adi, Mahesh, and I aim to break down these concepts. But before that, would you like to introduce yourself, Adi?
Hello, my name is Adi. I study further maths and physics for my A-levels, and I intend on studying computer science at university. One of my main reasons for studying computer science is artificial intelligence. Artificial intelligence is all around us. We live in an era where computers are dominating our personal lives through applications such as Facebook or Instagram, or watching Netflix, or buying a product on Amazon Prime. These applications can give us recommendations for products through personal assistants such as Alexa or Siri, conversational bots on marketing websites. Drone robots and electric vehicles use AI to navigate. Will the development of these artificial intelligences threaten or benefit society? So, AI is a very broad field of study within computer science, but it can be simplified to the development of computers to learn and reason like humans. Alan Turing, the father of artificial intelligence, proposed the Turing test for identifying whether a machine can think like a human. For the machine to pass the test, it is posed a series of questions, and if the answers are believed to be more human-like than a control subject being asked the same questions, then the machine is artificially intelligent. To pass the Turing test, the computer would need to have at least the following skills: natural language processing. It needs to be able to communicate in a natural language like English. Knowledge representation. It needs to be able to have knowledge and store it somewhere. Automated reasoning. It needs to be able to do reasoning based on stored knowledge. And finally, machine learning. It needs to be able to learn from its environment. This is where we can formally introduce machine learning as the ability to learn without being explicitly programmed. It is a subset of AI. So all machine learning is AI, but not all AI is machine learning. For example, a chatbot coded based on rules and complex decision trees coded into the system is AI, but not machine learning. However, if the chatbot is coded to take in more questions and terms and create more and more appropriate answers, then it is machine learning. Within machine learning, there is the subject of deep learning, and this involves artificial neural networks. Pranav, could you please explain more about what neural networks are?
So in order to get a true grasp of what machine learning and what the subsidiaries of that, which include deep learning and neural networks, we have to first of all look through the history books where we reach Frank Rosenblatt, who was a psychologist whose interest in the brain led him to believe that maybe we as a society and group of computer scientists were able to program a brain-like device. So this was unlike any of the ideas of the past that were used, which were heavily based around using complex mathematics to give instructions and allow for a computer to learn from a data set, which was the original way in which Turing and other such computer scientists envisioned AI would progress. However, Rosenblatt's idea of neural networks was to simulate a brain and all of the brain's functions by using weighting, which is the process of assigning a numerical value to something that is in a priority, which they then describe that as a weight. So same way that how we decide that certain things are more important than others, it's important the way in which the neural network will be built is so that it's able to prioritize various tasks above others, the same way that we would in, say, our brain. So the name of neural networks arose from the neuron, which is the nerve cell connected via axons in a vast system that we refer to as the nervous system. So this is the basic process of, this is the basic processing system of the brain, and this inspired research done by Marvin Minksy and Seymour Papier, who wrote a book named Perceptons in 1969, which speaks about single and multi-layer perceptrons. The book spoke about how the positives, and it outlines the severe drawbacks and limitations of using a single layer, as it is incapable of learning simple relations between multiple inputs and their corresponding outputs. So for those of you who aren't aware, perceptrons are simply, perceptrons are are items of hardware that are used in order to gain information, whether that be joysticks on a computer device or your keyboard or anything that takes in information and stores that information. That is a perceptron. Sorry. So then, unfortunately, Rosenblatt then died in 1971 in a sailing accident, which led to the decline of Euronet's research, because he was one of the only people that really believed that this had a future. So the entire landscape of AI might have been different if the man had survived, and however, the years that followed his death meant that the research into the idea of producing a neural network was heavily declined in that respect, because of course there wasn't someone spearheading the idea that they should continue, and instead mathematical AI continued to rise. So, however, though, in a wave two of sorts occurred in the 1980s when parallel distributed processing was released. So the one difference is back propagation, or backprop, as I'll refer to it from now on, where it was a method of multi-layer neural nets. Well, multi-layer neural nets can be trained. Unfortunately, I'm unable to explain this concept in great detail and the maths behind it, because that's currently beyond me. But the basic idea is that every time the program has an error, it propagates. So it goes through the entire network and all of the processes that it's completed, and then reassesses all of this information. So by using this, we can find the steepest way to descend this map. So if you treat all of the path in which we're going down, say this hill, which is how many of the leading computer scientists use this analogy. If we find the steepest way and the fastest way to achieve a certain goal, we then are able to achieve these things far more efficiently than if we were to simply just do various problems and calculations without testing for efficiency. And this is called gradient descent. So the parallel distributed processing book then caused a boom in neural nets as people then began finding new uses for this technology. But soon in the mid 1990s, there was research was once again out of favor. The research is once again out of favor, simply due to the fact that computers at the time could not handle some of the ideas that people had envisaged. So this boom caused a decline in other areas of machine learning. So the community turned away from the neural model once more. So going on a few years from that, then the third wave of neural nets then arose, which was the birth, let's say, of deep learning. So deep learning is a collection of related ideas that can be perceived in three different ways. So initially, the idea of having more layers, meaning the more layers that we can abstract. And for those of you who aren't aware, abstraction is the process of filtering out, or essentially ignoring, the characteristics that we don't want to concentrate on those, so that we can focus on those that we do. So, for example, if you have a tube map, you don't see the distances between the various stations, or you don't see any of the geographical features that might separate these things. Instead, you're simply given a map that is very, very easy to understand, of various colors and the stations. So although if you were to line up, say, a tube map with a geographical map and the stations accordingly, there would be heavy inaccuracies in that tube map. But this is done so that it's extremely easy for those to understand which train to take, because of course they don't need to know the information of what areas have certain lakes and where certain things are. They simply want to go from position A to position B. So by removing all of this unnecessary data, you make problems like this extremely easy to understand. And this is what deep learning intends to achieve. So the second way in which it can be perceived is that it has a larger number of neurons. So in 1990, the number that could be run was around 100. But in 2016, when the third wave took place, we could run we could run millions of neurons, and this obviously helped programmers achieve the ideas that were originally envisaged by their predecessors. And the third way in which this could be perceived is that neurons themselves have more connections. So there is more interrelated data, so that we could do greater in-depth network. So a greater in-depth network could be built, and using this information, deep learning was born, and these are based upon these three concepts. So now that we've achieved a state where we can take machine learning forward, as we have a lot more resources initially allocated to it, as well as more of the world's leading minds are dedicating themselves towards these fields. We can really see progress in these fields, and this is something that's extremely exciting. So with that, I'd like to then pass that over to Adi, who would talk about the ethics of these machine learning algorithms and how they would affect us in the future.
Thank you, Pranav. So my extended project qualification, which was a 10,000 word research project for my A level, discussed whether artificial intelligence would threaten or benefit society. So I first started by looking at the applications of artificial intelligence in general. This included the advent of fully autonomous electric vehicles, which would revolutionize the transport industry. Autonomous vehicles are self-driving vehicles. Some of these functions have already been introduced, like park assist, cruise control, but fully autonomous vehicles are being developed at a rapid pace by many new and existing auto manufacturing companies. Political policies are adapting to bring in the new infrastructure to make this possible. Their functionalities are based on motion sensor technologies, which incorporate machine learning. These algorithms help in reducing the dataset by detecting object edges and fitting line segments, polylines, and circular arcs to edges, all of which help to form the features that are used for recognizing an object. Directional movement and speed changes in vehicles are dependent on the level of confidence of these algorithms and in the classification, recognition, and prediction of the next movement of these objects. Commonly used algorithms being gradient boosting and ADA boosting. There are several applications of machine learning in medicine. Investigations leveraging computer-aided diagnostics have shown excellent accuracy, sensitivity, and specificity for the detection of small radiographic abnormalities, with the potential to improve public health. Analysis of screening mammograms shown that artificial neural networks are no more accurate than radiologists in detecting cancer, but have consistently shown high sensitivity for pathological findings for subtle lesions. Another example is the increased ability of machine learning algorithms to detect early and subtle changes in MRI, leading to the earlier diagnosis of a potentially life-threatening illness and earlier institution of treatment. However, there are some drawbacks to artificial intelligence and machine learning. The New York Times, working with the Observer of London and The Guardian, obtained a cache of documents from inside Cambridge Analytica. Both Facebook and Cambridge Analytica were placed under intense scrutiny and investigations. The documents proved that the firm used data improperly obtained from Facebook to build voter profiles to influence US presidential elections. Cambridge Analytica, eager to sell psychological profiles of American voters to political campaigns, acquired the private Facebook data of tens of millions of users, potentially violating American election law. This has serious drawbacks because for legislation, there is not enough legislation to prevent this sort of attack from happening, and these can cause major bias towards a certain president, such as Donald Trump. Other companies partnered with Cambridge Analytica to obtain Facebook data for psychological profiles of voters using AI. Then there is the ethical dilemma of deepfakes. These use AI called deep learning to make images of fake events. They are typically used to mislead the public by creating slander against famous and important personalities for political and monetary gains. Most often they are videos or photographs. Many are pornographic against female celebrities, with their faces swapped onto clips of porn performers. Audio can be deepfaked as well to create voice clones of public figures. They are made by running face shots of the two people through an AI algorithm called an encoder, which learns similarities between the two faces and reduces them to their shared common features, compressing the images in the process. The next AI algorithm, called a decoder, recovers the faces from the compressed images. One decoder receives one person's face, and the other decoder receives the other person's face. And then the decoder images are swapped for every frame. These videos are created on high-end desktops with powerful graphic cards or with computing power in the cloud, markedly reducing the processing time. As the technology becomes more accessible, deepfakes could mean trouble for the courts, particularly in child custody battles and employment tribunals, where faked events could be entered as evidence. But they also pose a potential security risk. Deepfakes can mimic biometric data and can potentially trick systems that rely on face, voice, vein, or gait recognition. The potential for scams is clear. On the other hand, governments, universities, and firms, including Microsoft, Facebook, and Amazon, are leading the research to detect deepfakes by AI, which can be trained for detecting celebrities on hours of freely available footage. Further research is required to develop detection systems to flag up deepfakes regularly. A blockchain online ledger system could hold a tamper-proof record of videos, pictures, and audio, so their origins and any manipulations can always be checked. I researched the applications of AI in several other fields, and overall I came to the conclusion that AI is beneficial to society because of its unprecedented potential, but the lack of responsible legislation should be taken into account.
So, Adi, to backtrack or back propagate through your information, one of the leading companies in the automated industry, the automated vehicle industry, is Tesla. And of course, in earlier episodes, we've spoken about Elon Musk's company and the way and the influence that he has on markets and other such fields. But how do you believe that, say, having a Tesla and using its autopilot function is something that you would consider in the near future?
Yeah, I will definitely consider it because it's something which is obviously going to be the future. Self-driving vehicles. I mean, there will come a time when there will be an accident or two, but at the end of the day, if everyone's using it, then the likelihood of this is 1 in a million. And quite clearly, it's actually going to be safer using machine learning vehicles because they're less likely to have incidents with other vehicles because they'll be able to communicate with those vehicles.
Yeah. So one of the big issues that people have in this field is that although the statistics do show that the amount of vehicle crashes and accidents that take place on a day-to-day basis are enormous due to reckless driving, possibly drunk driving, and other such human error issues, and that companies like Tesla and other such automation companies would look to reduce these amounts of casualties and accidents. It's important, though, to consider that when there is a DUI incident or an accident that takes place due to someone's misjudgment and lack of and human error, in essence, it's important to assess whether or not the blame and who should be reprimanded for this occurrence, whether that should be placed on, say, the company that built this AI or the person for not stepping in and controlling the AI earlier before a crash were to occur. Because of course, if you were to see that, say, there's a truck coming your way and your car's just gone into the wrong lane, then you do have the ability right now in a Tesla to turn your car around and get out of the way. But as many of you might have seen, that there are videos of people with a Tesla autopilot car just driving whilst asleep, or sometimes like turning around and eating food or talking with their friends. So because of how safe people feel right now inside of these cars without really having to worry, you create a weird precedent of you rely so much on these machines and you really trust them. So there are obviously two sides of the spectrum. Half people who use cars and obviously need to get around, their belief is that you can fully trust these machines. You can sit down, you can not worry, and you can talk to the person in the passenger or even behind you without having to worry on the road, which is what Elon Musk and Tesla aim to do in the near future. But right now, of course, there is always going to be a risk because we haven't tested that on such a large scale. Not that many people in comparison to the whole world have a Tesla. So the machine learning algorithm that is used hasn't been built to the extent at which, say, normal people who've learned to drive cars has. So when it comes down to assigning blame or finding who's at fault for these things, you reach heavy ethical gray areas where you can't really make these decisions. So what is your opinion about that, Adi?
So at the moment, with the way things are going, artificially intelligent vehicles will be on the road with other vehicles which aren't artificially intelligent, which is a problem because if they aren't all artificially intelligent, they won't be able to communicate with each other, and hence they won't be able to detect whether a collision is imminent. And if a collision is imminent, say there's a pedestrian on the side of the lane, would the car rather crash into the other car or crash into the pedestrian? And that's again a serious ethical debate, considering there isn't detailed legislation on how to tackle these events because all of these technologies are relatively modern and hence they aren't. It hasn't been around long enough to hold legislation. So yeah. It's a very serious topic, but I feel like it's going to change because of the way artificial intelligence is constantly improving. These machine learning algorithms are constantly improving. They're going to make them more secure for the drivers in the cars. So at the end of the day, it will be safer. Everything will be safer because of the way these algorithms improve through trial and error.
So going back to the way in which people use the analogy of if a car has to decide whether or not to kill one person or move and then kill five people or these sorts of problems. Oh, well, sorry, it'd usually be the other way around, right? So whether it continues in a straight line and kills five people or goes off and wavers and kills one person, the social standings of these people are taken into account and all of this other debate. However, whilst I was reading the Road to Conscious Machines, the story of AI by Michael Waldridge, he discussed this problem as well, and he comically referred to how this scenario is so unlikely, and yet everyone, whenever the topic of AI and automation vehicles comes up, people always decide to come back to this analogy that people use. So despite how unlikely this is. Like no one has ever actually, well, not to my knowledge, but I don't think anyone has actually ever had to face this issue whilst they were driving a car. And this is sort of the area that people who are against handing over such responsibility to machines, maybe due to fear or due to the risk of what this will have on lower paying jobs such as taxi drivers, bus drivers, and all of the other fields that revolve, well, lorry drivers as well, and all of the other fields that require people to simply drive a car from point A to point B. So with this is a big argument that people like to bring up in this sense, but inherently this is pretty useless when you think about the ways in which no one has actually, well, not to my knowledge, I think maybe one or two cases in the history of vehicles might have had this scenario, but I don't really think that this is something that we should really be worrying about on a day to day. But with that, we also have to look at how this will affect car culture and the huge industry that is built upon selling classic cars or purchasing engine parts and certain motors and the noises and the atmosphere that is built around classic or even modern day supercars, which is obviously a billion-dollar industry with so many people dedicating their lives to restoring old cars or building cars from scratch and taking apart vehicles that are petrol or diesel based. So this is a big shift that people would have to get accustomed to. And right now, of course, there'll be heavy blowback on that front because the people who are heavily invested in these areas aren't fans of just a Tesla or something that looks futuristic to simply say there's no way you can pull out wires and change stuff and personalize your car, because of course that could be extremely risky if you would say dislodge a camera or a sensor that would be used in your driverless car experience. So with all of this considered, there's a lot of blowback from the car community about driverless cars, and this is something that I've seen whilst watching Car Masters and Rust Valley, which are both series on Netflix, which follow various car enthusiasts on their efforts of trying to restore or even build brand new cars based upon, say, older designs. So and then of course flipping it for money, and that whole aspect as well is heavily shown in the show. I'd highly recommend anyone wanting to watch this if they were interested in cars. So with all of this considered, it's important that we take into account the opinion of the car enthusiasts and the people that build their lives off of such industries, such as taxi drivers, lorry drivers, bus drivers, and that area as well. So what would your response for that be, Adi?
So there are two types of driverless cars. There are ones which use camera technologies, and then one which use LiDAR technology. So LiDAR technology works by scanning the area, having essentially a 3D profile of the area, whereas camera technologies only operate on 2D profiles, but they use heavy machine learning algorithms to make sure that their knowledge of the surrounding area is still accurate. However, this has some drawbacks. For example, in foggy or stormy weather, it is quite clear that a 3D LiDAR technology with being able to accurately picture the surroundings regardless of the weather or whether there's frost or fog or whatever. Yeah, so in that case, LiDAR technologies would be more accurate at detecting these kind of problems. Yeah, so on that front, there are definitely more advantages to these kind of autonomous vehicles.
So with the introduction of AI into pretty much every field that we use for, say, earning money and people look to get into after education, there has been so much automation and so much change in the job market that it's important that we, of course, consider those who would be in the jobs that are currently filled by AI devices and machines, which would heavily restrict these people's livelihoods and their chances of achieving certain life goals, because they're unable to find a job in these sectors that they might have worked their entire life in order to achieve. So, say if we were to make perfect machine learning cars and everyone accepts this, whoever's trained in a mechanic school or spent years of their life researching cars and looking to get into this industry, they would of course heavily be negatively affected by this. So it's important that we understand the ways in which people can be affected by simply deciding that we have to get rid of all normal cars because they're dangerous and instead opt for artificially intelligent cars, which are far more safer because of all of these various drawbacks and their impact on society. And this goes for many fields as well. So usually you'd have call centers, but which are now being replaced by AI. And call centers would have been the usual job that, say, someone studying at university decides to do on part-time in order to pay off loans or other such expenses. And now these jobs are unavailable to them, and instead they'd have to go for even for lower down jobs. And you're seeing in certain areas like San Diego where robots are used to deliver people's Uber Eats. Of course, right now this is an extremely limited service that is available to people, because I think they only have about 10, 15 robots in the entire of San Diego. So they won't be able to really do influence much there. But of course, in the future, will be a company like Uber would be looking to reduce the amount of expenditure they have on people's wages and other such fields. So robots would be the way forward because, of course, it all boils down to how robots do not require pay. There's no expense when you have something like this. Robots can't go and claim insurance after they crash their bike or something like that. And instead, all the issues are kept in house and aren't open for public scrutiny. So that's why these companies would prefer to use AI or robotics in order to automate some of these fields, which are which heavily go back to the point of what point do we stop? At what point do we decide that we have automated so much that there's no longer viable jobs for people who aren't, say, the world's leading computer scientists or the world's greatest medicine practitioners or other such extremely high intelligent fields, which require, well, years of study, years of dedication, and these sorts of avenues. And you pretty much cut out the entire chance of someone who, say, hasn't dedicated so much time in their lives, or maybe is incapable of uh, achieving such academic progression because of these various shortcomings in their life, which may be due to family issues or just simply being unable to understand certain concepts. So, uh, with that said, the goal is that many proposed when the inception of AI started was that in 100 years' time we'd have automated everything. So people focus now more on art and focus more on uh, all of the fields which, well, we believe can't be automated, like improving mental health, improving physical health, improving the way in which people speak to each other. Because of course, right now we're in a position where social media and other such other such applications heavily dictate our lives and the way in which we speak to each other. So by reducing this sort of middleman and making all of the jobs and all of the ways in which people interact far more accessible and far more friendly, you do improve quality of life. But then you're looking towards a science fiction novel version of how the world will end up, which is scary for some people who say look to really dedicate their lives and look to achieve more than those sitting next to them. But if there's no incentive to work and there's no reason to work because every single job that can be done is already being done by these machines, you're in a position where you either have those people who are on extremely strict self-improvement programs of constantly looking to improve their lives and making themselves as stress-free as possible, or you go on to the other side of what currently is already available, but those who look to do heavy addiction to, say, gaming or drinking or other such avenues which heavily deter their quality of life. So when you have this sort of dilemma, which we will have to face in the next 50 to 100 years, it's important that we discuss the ways in which this will affect us, because of course we'll be navigating these unknown waters. So how do you believe that we should address these sorts of well, might seem far off, but how do you believe that we should address these possibilities, Adi?
Yeah, so I agree with you. Automation is like the advent of artificial intelligence does bring up all these questions like, will we have any jobs left in the future for us to handle? But I will say that automation has been around for several decades. Innovation has always made human work easier, which has meant fewer old jobs, but new and often better future jobs. Although productivity rose as living standards improved, disruption in technology meant revolutionizing the old ways. Advancement in the manufacturing industry has meant that new jobs could be created that were better. Jobs have been taken over by machines much faster than in the past. So, for example, in medicine, the requirement for trained and skilled radiologists will be markedly reduced as AI and machine learning algorithms will be able to provide diagnoses of clinical pathological conditions based on learning from huge amounts of data. to be able to guide treating physicians and interventionists to treat different medical conditions. I mean, currently technology can generate 3D models of various tissues and organs, and thus surgeons can accurately plan surgery for a particular patient, which means that they're using the technology alongside what they're doing right now, which is something that is going to be happening in the future. AI won't take us over. It won't replace us. Instead, we will be working alongside it to make our lives easier, as we have worked alongside machines in factories to improve labor, and also robots. You mentioned robots. They've been used for many decades in the automotive industry and several other industries to automate production and reduce labor costs. This has vastly impacted on jobs. In 1979, General Motors employed more than 800,000 workers, making about 11 billion US dollars. In 2012, Google made $14 billion, but only employed 58,000 workers. In 2004, Blockbuster had 84,000 employees and made 6 billion US dollars. But in comparison, in 2016, Netflix had 4,500 employees, but made 9 billion US dollars. So it's quite clear that the number of jobs is going down and it is causing problems. But at the same time, we're working alongside it and creating better jobs in the future. So services, like the service industry, would be massively affected by robots, but at the same time, those people would go on to do better jobs and have better educations and just generally have a better standard of living.
So with all of this considered, you can clearly see now why myself and Adi and many people in our close friend group decide to study computer science at a higher level, because we believe that we can be part of this new technological era where we automate so much. And I believe that myself and Adi really want to be the forerunners of this sort of technology and after our education. So that is pretty much why we've decided to study computer science at a higher level and why we're so interested in the subject. So for anyone who is, say, looking for a field or looking for what to be interested in that sense, because of course this podcast is aimed towards those who are in, say, secondary school or aiming to improve, to get a better understanding of which career path and which profession to go down. We would definitely recommend going through the AI route because of how global and how important these technologies are when it comes down to deciding future jobs and other such avenues. So with that, I would like to conclude today's episode of Intelligence Dive. I believe it's been a great experience talking to Adi about all of these various machine learning, artificial intelligence, robotics, deep learning, and all of these other fields that might not have been public knowledge or might not have been widely known before this. So with that, I'd like to thank Adi for coming onto the show today.
Thank you very much, Pranav. Very much appreciate it. And just to conclude what you've said, AI is the future. We know that already. But it's important to have an open mind when you're applying for university. It's important to be aware that there are several other fields in computer science which are very interesting as well, such as systems and parallel distributed processing, as Pranav mentioned earlier on. And I think that if you want to combine that with artificial intelligence, that is equally good. Like it's all very open. You're free to make your own decisions.
So of course, we are also looking to benefit off of the machine learning algorithms used in YouTube and other such applications. So please do like and subscribe this video so that we can show up on more and more people's recommended sections, and we can improve on our podcast and our production level on that sense. Many thanks to everybody who's stayed until the end of this episode. We'd like to thank Adi once again for coming onto the show, and we'll see you all next time.